Hello everybody, welcome into another lesson. So today we are going to apply properties of exponents to variable expressions. And in this particular lesson we're going to do it with them in base and rational exponent form. Next lesson we'll do it with base and radical form. But here, for the sake of this lesson, we're going to assume that every value of x is positive. The reason for that is that if we had any negative values or zero values, if we ended up having the x in the denominator, for example, and it were zero, you'd have an undefined expression. And then if you have an even root, you would have something undefined because you'd have imaginary numbers. So that's why we're going to assume x is positive for this lesson. But here you have x to the 1/3 times x to the 1/5. Well, you're just going to add the exponents, right? So just add your 1/3 plus your 1/5. Well, let's see, that would give you 5 plus 3 over 15, which would end up giving you 8 over 15. So this would literally turn into x to the 8/15ths is what you would get. You could write it like that, or you could write it as the 15th root of x to the 8th power. That's either way, you could write it in either form, but you would get x to the 8/15ths or the 15th root of x to the 8th power. Either form would be acceptable. Alright. We have the quantity of y to the third, that quantity to the 1/6 power. So we have a power to a power, y to the third raised to the 1/6 power. We're just going to multiply the exponents. Well, 3 times 1/6 is 1/2. You would get y to the 1/2 power, or simply the square root of y. That's exactly what you would get. Get y to the 1/2 power, or the square root of y. Well, assume all variables are positive. I know we didn't have x. We're going to assume all variables are positive. Alright. Whoops, that'll be in the next lesson. We have 1 over x to the negative 5/4. So we have 1 over x to the negative 5/4. Well, first thing, you have a negative exponent in the denominator. That means it's going to go up into the numerator and become positive. So this would turn into x to the positive 5/4. Well, can we simplify this? We sure can. X to the 5/4, isn't that the same as x to the 4/4 times x to the 1/4? It sure is, because you add 4/4 and 1/4, you'll get 5/4. Well, what is x to the 4/4? That's just simply x to the first, or x. You would end up having x times x to the 1/4, or x times the 4th root of x. That's exactly how you could write that. So in the end, you'll end up getting x times the 4th root of x. Alright, let's see. We have x to the 3/7 over x to the 1/3. Alright, so x to the 3/7 over x to the 1/3. Well, the power in the numerator is definitely greater than that of the denominator, right? So this is going to favor the numerator. So let's take that 3/7 minus the 1/3. Well, let's see. So that would turn into 9 minus 7 over 21, which would end up giving you 2/21. So this would end up turning into x to the 2 over 21. X to the 2/21 power which is the same as the 21st root of x to the second power. You could write it in either format, but x to the 2/21 or the 21st root of x to the second power. Alright, let's see. We have x to the 5/3 times y all over x y to the -1/2. Alright, so since you are dealing with two variables, it might be a good idea to split them, right? Because this is x to the 5/3 times y over x times y to the -1/2. So we could split all the factors, we could split all the x into their own like this. So we could split it into x to the 5/3 over x times y over y to the -1/2. Alright, so the first one here, the first term, so 5/3 is definitely greater than 1, right? If you subtract 1 from that, you would end up getting 2/3. You'll end up having x to the 2/3. Now, for your second term, 1 is definitely greater than -1/2, right? So if you take 1 minus -1/2, that'd be 1 plus 1/2, so you'd end up getting that times y to the 3/2. Okay, so you have x to the 2/3 times y to the 3/2. Well, we can definitely factor the y further, because 3/2, so here's x to the 2/3, but the y to the 3/2, isn't that the same as y to the 2/2 times y to the 1/2? It sure is. So if you factor this further, you'll end up getting, you would have y times the cube root of x to the second power times the square root of y. That's the best way you can factor that, since you have y to the 1/2. So you'd end up having y times the cube root of x to the second power times the square root of y. It's bugging me. I'm sure it's bugging you. I'm going to assume all variables are positive. Alright, there we go. Now I've corrected it. Alright, let's see. We have y times y to the 1/4 raised to the 4/3 power. So I have y times y to the 1/4, that whole quantity raised to the 4/3 power. Well, order of operations dictates that I deal with what's inside the parentheses first. So if I add 1 and 1/4, what do I get? I'll get y to the 5/4 would be raised to the 4/3 power. Now we just take 5/4 times 4/3. You'd end up getting y to the 5/3 power. So we have y to the 5/3 power. Can we simplify this further? Yes. Y to the 5/3, that's the same as y to the 3/3 times y to the 2/3. Well, y to the 3/3 is just y. So you'd end up getting y times the cube root of y to the second power. And that's how this would simplify. You get y times the cube root of y to the second power. three variables. Let's see, we have x to the 3/4, y, z to the negative 1/3, all over x to the 1/4, z to the 2/3. All right. So we have x to the 3/4, y, z to the negative 1/3, all that all over x to the 1/4, z to the 2/3. We have three variables here, so we should probably split this into three parts. So we'll take x to the 3/4 over x to the 1/4 times, well, just simply y, you only have a y in the numerator, times your z to the negative 1/3 all over z to the 2/3. Alright, now we can take this each piece at a time. So for your first term, 3/4 is definitely greater than 1/4, right? So 3/4 minus 1/4 is 2/4, or simply 1/2. So you end up getting x to the 1/2, then just times y. Now, for your third term, 2/3 is definitely greater than negative 1/3, so we're going to favor the denominator. So this would turn into 1 over, let's see, 2/3 minus negative 1/3 turns into 2/3 plus 1/3, or just 1. So that would be z, so this would be times 1 over z. So you have x to the 1/2 times y times 1 over z. Well, this will just simplify into y times the square root of x all over z. That's how that would simplify. Y times the square root of x all over z is what you would get. And I think that's all she wrote for this lesson. So that's it for properties of exponents and with variables in rational exponent form. Next lesson we'll deal with them in radical form. So I hope everyone has a great day. Take care.